Welcome to The Explainer. Today, we are diving into something pretty radical, a totally different way to think about decentralized storage. It's called the Deterministic Storage Model, or DSM. And let me tell you, it throws out a lot of the things we thought were absolutely necessary for these kinds of networks. So let me just start with a big question to get you thinking. What if you could build a secure global network, but with no blocks, no leaders deciding what's true, and no special group of validators? I mean, it sounds kind of impossible, right? But that is exactly the puzzle that DSM tries to solve. All right, so here's how we're going to break this all down. First, we're going to rethink what digital trust even means. Then we'll get into the core idea of dumb nodes, smart clients. From there, we'll dig into the specific rules of storage, see how this network runs without any leaders, and then check out the seriously cool trustless tools you can build on top of it all. Sound good? Let's jump in. Okay, first up, rethinking digital trust. And really, what this all boils down to is a massive shift away from trusting people and complex systems and toward trusting pure, verifiable math. And this is where you can really see the difference. Most networks rely on trusting the infrastructure. You've got complex validators, voting systems, all these economic games designed to keep people honest. Well, DSM just flips that whole model on its head. It trusts math. The nodes are kept incredibly simple, the outcomes are totally predictable from public data, and the security, it comes from cryptographic proofs that anyone, and I mean anyone, including you, can check for themselves right on their own device. So how does it actually do that? Well, that brings us to the core philosophy of the whole system, this idea of dumb nodes and smart clients. It's a real aha moment. And to really get that philosophy, we have to talk about this word, determinism. All it means in this context is that everything works like a perfect math equation. You put in an input, you get an output. And if you put in that exact same input 1,000,000 times, you will get the exact same output 1,000,000 times. No exceptions, no randomness, no ambiguity. This leads us to the central design goal, and you can find this right in the spec. It says, DSM maximizes determinism and minimizes trust in infrastructure. Seriously, every single design choice in this system flows from that one powerful idea. And here's the best way to think about it. Imagine the network's nodes are just a bunch of self-storage units. Their job is super basic. They store your digital boxes and they enforce a few simple rules, like don't take up more space than you paid for. They never look inside the boxes, they never sign for anything, they're dumb. All the intelligence, the key to your lockbox, knowing what's inside, and the job of verifying it's all correct, that all stays with you, the smart client. Okay, so let's get into the nitty-gritty. What are the actual rules that make this work? How do these dumb nodes prove they're doing their job if they're not signing anything? Well, rule number 1 is the absolute foundation of everything. All data is encoded in a super strict, deterministic way using something called protocol buffers. Now, this might sound like a technical detail, but it is absolutely crucial. By banning other formats, the system guarantees that when my computer and your computer look at the same data, we see the exact same sequence of ones and zeros. It kills any possible ambiguity right from the start. And that leads to this thing called a byte commit message. Think of it as a node's public report card. And it's so clever. Look, there's no timestamp, just a simple counter, which is what makes the whole system clockless. Then there's this SMT root, which is a single cryptographic fingerprint for all the data the node is storing. It also reports how much space it's using, and, this is key, it links to its previous report. This creates a chain of events, like a public audit trail that anyone can download and check to make sure the node is playing by the rules. So if nodes are just publishing these simple little reports, how on earth does the network manage itself? I mean, how does it decide to add new nodes or remove old ones without any leaders or voting? This is where that deterministic magic really starts to shine. It's actually genius in its simplicity. Nodes don't vote, they just signal. When a node starts to get full, it publishes a verifiable up signal. If it's nearly empty, it publishes a down signal. You, as a client, can just collect all these public signals and count them up. The difference between the ups and the downs is called the position delta, and it tells the whole world, deterministically, if the network needs more space or less. It's a calculation, not a consensus meeting. So, what if the network needs more nodes? It runs a totally deterministic lottery. It's so cool. Anyone who wants to be a node operator applies. Then, a unique salt is created from public data that everybody can see. Then you just rank every applicant based on a hash calculation. Whoever has the lowest number wins. It's a lottery, but it's a lottery where the outcome is totally predictable if you have all the public info. No backroom deals, no committees, no bias, just math. All right, so you've got this incredibly simple, predictable, rock-solid foundation. What can you actually build with it? Well, it turns out you can build some really powerful applications. Let's look at one of the coolest examples, the deterministic limbo vault. Okay, imagine you want to lock up a digital asset until some specific condition is met in the future. With a deterministic limbo vault, or DLV, you start by publishing what's called a pre-commit. That's just a fancy word for the hash of a secret that only you know. It is exactly like putting a locked box out on a table for everyone to see. Everyone sees the box, but nobody knows the key. So how do you open the box? You just reveal the original secret, the key. At that point, anybody in the world can take your secret, run it through the same hash function, and see for themselves that it produces the exact same lock, the pre-commit, that you published earlier. That mathematically proves the condition has been met, and the vault opens. No bank, no server, no trusted middleman needed. And that's just scratching the surface. These same deterministic ideas can power all sorts of things. You can create verifiable contact lists between devices without a central server. You can have digital assets where the rules are literally baked into the asset itself. You can even have a system where node operators can get their security deposit back just by proving their storage is empty. No permission slip required. So let's just zoom out for a second and bring this all home. Let's talk about the deterministic difference. Why this whole obsession with predictability really matters. You know, if you take away just one thing from all this, it should be this. DSM represents a fundamental shift in where we find truth online. It moves the source of truth away from a small group of trusted, and let's be honest, fallible actors in the middle of a network. And instead, truth is defined by a set of mathematical rules that anyone can verify and that are enforced at the edges, by us, the users. You don't trust the infrastructure because you personally can verify it. And that just leaves us with this final, really fascinating question to chew on. If a system state can be perfectly predicted just by looking at public information, what does that unlock? What new kinds of truly autonomous applications could we build? I mean, think about a DAO that runs entirely on publicly auditable logic, not on votes. It's a pretty mind-bending idea, and it might just change how we build the next generation of decentralized systems.